Good afternoon, everyone, and welcome to our webinar today, Real-Time Data-Driven Design, where we're going to look at some of the simulation extensions and their capabilities within that are available for Creo. Specifically, we're going to look at some of the Ansys simulation capabilities for those extensions. Last week, we looked at Creo Simulation. So I think that makes February Simulation Month. So welcome to the webinar. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HCI, and leading our demonstration today is Paul Dye, who's a solutions consultant and applications engineer with PTC's Virtual Center of Excellence. Paul always does a great job on these demonstrations. We're also going to show you today a comparison of the differences between the simulation tools and a little glimpse of what is going to be coming out soon for an additional simulation tool for Ansys. Also on the panel is our Director of Marketing, Jeff Gabbio. So without further ado, Paul, take it away, my friend.
All right, thank you very much. So thank you, Rob, for having me on. Thank you, everybody else, for joining the webinar today. So happy Simulation Month. Very great topic that we have, and something that is constantly evolving at PTC and Creo in general, something that we put a lot of time, money, and effort into. So definitely something that I can understand can be confusing if you haven't worked in the area of simulation, specifically in Creo, but I'll be able to explain some of the differences, really where everything's meant to be utilized, and go through and kind of explain the breakdown and really focus in today mostly on what we have around the Creo Ansys simulation. So really looking at analysis in general, we typically see some challenges that we need to be able to address. And first and foremost, you need to understand how your products are going to perform in the field. You need to understand how they're going to react in different situations, how they're going to perform just under normal operating conditions. And also you need to be able to incorporate that into the way that you do design. You don't want to just keep it as a way to do pass or fail. You want to be able to really build that into the design of the model itself. And analysis is a great way for getting that type of feedback, but you typically see that designers, engineers feel that they don't have the expertise that you typically need to run simulations, especially as you begin to refine and get further along into the detailed design portion of the design process. What we normally see is engineers have to consult an expert or send it out to a third party to do the analysis. Most times it takes multiple different iterations back and forth just to get some type of analysis done, even before you would get into a prototype, let alone a verified product. It's a very disruptive process. Something you may have seen slows down your design cycle. A lot of times just leads to people avoiding it entirely. That's something that we want to avoid. That's definitely an issue with the way that we've really seen analysis done traditionally. And what we did was take all that into account and really a lot of other challenges into consideration and partnered up with Ansys to provide solutions right here from within Creo. So the very first tool a few years ago that we built out as part of our partnership with Ansys was Creo Simulation Live. This may be a tool that you've heard or seen before. This is integrating their Discovery Live engine directly into Creo Parametric, where it's meant to be used as a design tool to build out better designs, and you're starting that right from the beginning of the process. So a very strong tool that has some very useful capabilities. But what we're doing now is taking the partnership a step further and introducing Creo Ansys Simulation, which is taking high fidelity Ansys powered solvers and putting them into the hands of the designer or engineer that would need to use them. And first and foremost, it's a very comprehensive tool for doing your linear static analysis, works in multiple different use cases for structural, thermal, modal throughout that process. And I'll go through and show what this looks like. You're going to have a simulation tree where you can set up and manage your different studies that you're working with. You can even copy and paste loads and different constraints between your setups. It's meant to be very fast to go through and try out different types of use cases. And setting up the studies is very straightforward. All the loads, the constraints that you're working with, they're allowing you to set up very realistic situations in a way that works well for just your Creo designer or engineer. Even if you had a setup that was done over in Creo Simulation Live, something that was done earlier on in the process, that can even be used as the base for a study and then applied to Creo Ansys Simulation as well. So working between those two is a breeze. And also another great capability that you're working with in Creo Ansys is automatic meshing and contact handling. There's no need for you to have any prior meshing expertise or knowledge in order to build out very accurate meshes. very quickly. You do have more advanced options for controlling the mesh that you're working with or refining it in certain areas that you want to focus in on. And again, handling contacts is done in a very similar way. You're able to have the system automatically detect contacts for you, but you do still have the ability to manually define those contacts as well if you'd like to. And again, it's Ansys. The same exact technology that's used in their platform is being used here to give you some very high fidelity results. The results that you're getting are very visual, very interactive. You have a fully customizable results legend to display both basic and more advanced results. You have the ability to query anywhere on the model to interrogate certain spots that might be of interest for you. Simulation probes can also be used to monitor different values. Even as you go through and make changes to the model, it's going to be able to update around that. And probably the greatest thing about this tool is the full integration with Creo. Everything that you're doing is in the same consistent user interface. So if you've used Creo in the past, you're already halfway there to knowing how to use the tool. Another big thing with that integration is the fact that you don't have data translations. It's the same model and geometry that you built out. It's the same model that's being used in Creo Ansys Simulation. Even if there's changes to the geometry, again, full associativity down the line to any of your analysis information. And one thing to note, if you did want to take the analysis further, you do have the option to export that simulation study to be used over in the full Ansys Workbench platform, probably more than likely being done by the dedicated analysts or the experts there. All right, and with this, we can go ahead and show what this looks like here in the context of Creo. If you have any questions on this while I'm going through the demonstration, or you wanted me to explain anything further, definitely feel free to drop that in the Q&A. But with that, I can go ahead and switch over here and jump right into it. All right, so for our demonstration here, I'm going to be using a data set from one of our customers, Royal Enfield. Specifically, this is going to be the rear arm assembly model off of one of their motorcycle designs. And one thing to note is, again, we're just staying right within Creo. We're just going to go through and work into a standard structural analysis. You can see here that we have some base forces laid out on the right-hand side of the model, probably where it's going to be connected back in with the main part of the assembly. We also have a displacement constraint. I can go ahead and add in another one here so you can see what this would look like to add one of these in. It's very straightforward. You simply just select on any of the surfaces that you'd like to constrain. Go ahead and take that down to the bottom here. Move that up to the top. And we're good to go. Now we have most of the base setup complete here, but with this being an assembly model, one thing that we'll also need to do is define the different connections between our various parts. We could do that manually if we'd like to, or we could have Creo Ansys Simulation automatically detect those contacts for us as well. All right, and once we have those contacts detected, you can see here we're able to go through and lay out a bit of the mesh here. So this is our mesh control tool. In our case here, if we want a higher resolution mesh, we can go ahead and drag our mesh resolution over to the right-hand side. As you can see here as well, we also have more options to specify some of the details of our global mesh. So you could go through and have edits and have control over this if you'd like to. Local mesh refinement is also another option that we could choose, but in our case, we'll go ahead and simply generate the mesh. This mesh generation process is run by the same solver, so the time it takes can depend on the size of the model, but you're always able to monitor the progress and the status of the mesh generation down here in the process manager. And once that mesh is generated and all the setup is complete, we can go ahead and run the analysis. So let's go ahead and let that go. We can again use the process manager down here to monitor the status of the simulation studies that are being run. While it's running, it displays the number of processes that are being run, as well as any of the ones that would be completed for the current session. And again, the solver, the meshing technology that's used here in Creo Ansys Simulation, it's the exact same technology that powers the Ansys Workbench platform. It's part of the reason why it's so easy to move between the different applications. You can start your studies over in Simulation Live, refine the results here in Creo Ansys Simulation, and if you wanted to, you could export out to the full Ansys tool to further expand upon the capabilities, a bit more specific to the analysts in that case. Okay, you see that that was fairly quick to run through and complete. And now we can move over and check out some of the results that we got. Now with results in Creo Ansys, there's going to be two main categories that you work with. You have basic and advanced. So here we can see some of the basic. You get things such as von Mises stress, displacement magnitudes, displacement in the different directions. You immediately have access to those. You can see that visualized right up here on the model. We're getting a max von Mises stress of around 85 megapascals right now. can also see that Creo Ansys highlights the max area right on the model itself, so you can get a closer look at any of those. And it seems to be pretty similar over on the other side. If you want to get more specific information on that, we could do a simulation query that pulls up values at specific points of the model. Another option that we have here is to place a simulation probe on the model. These exist as part of the analysis model. They can update for different variables, for different result types as the study is being run, or even if you make changes to the study itself, the values that you're getting there are going to update as well, which you would just do right over in the simulation tree in the results tab. And at any point, you can simply turn those off or on as you see fit. Another area that I have of interest here is going to be the displacement in the model based on the loads that I have laid out. I'll go ahead and have this added into my results here. Have a contour plot applied to the model to view that. And because I defined that after the analysis was run, I'll just simply update the results for the new areas that I want to look at. And once those results are updated, we can go ahead and take a look at what we got here. All right, from those loads, we're looking at a max plate displacement of around 0.02 millimeters. We could get a better understanding of that by animating on the deformation. You can see exactly how the model is going to react. You could also turn off or on the mesh visualization, different options there. But what I want to do now is move into refining my analysis. Based on some of the initial results, I know the areas where I'm seeing the most amount of stress. So what Creo Ansys simulation allows us to do is add selective detail into that mesh and get even more accurate results in specific areas that we define. On my model here, we saw the most amount of stress occurring at the outer or inner surfaces of these brackets. We'll create a finer mesh in those particular areas. What it's doing in that case is overriding the global size settings that we initially had set for the model, and then allowing us to get even more detail into the areas that are going to be important for us. And we'll let that go through and regenerate the mesh. And once that's complete, we can go ahead and see the visualization of that. Let's go ahead and display that up. And now looking at the inner surfaces, you can see that each of those areas are going to be a smaller element size, meaning that we're going to get even more accurate results in those particular areas that we defined. And then anywhere else that's not as important, we can leave as a larger mesh. Okay, so now that I've gone and refined the mesh based on my initial findings, what I want to do now is rerun through that study. We can again turn back on the probe that we had set from earlier and go back up to the top and run that study. Similar to before, while it's running, we can open up the process manager and see exactly how far along the study is. If we open up the breakdown of that progress, you can see that it shows the completion percentage for the mesh, the solve for the analysis itself, and then for the results that we want to display. And once it finishes up, which doesn't take very long at all, we can go ahead and take a look at the updated results. Let's first look at the von Mises stress. Pull that up here. And it looks like it's actually increased a bit from where it was before. Probably going to be a bit more of an accurate result there. It's located in almost the exact same spot, but the value has increased there. So getting more and more accurate results in that area. Go ahead and open up the probe that we had over here on the right-hand side of the model. That value has actually increased a little bit as well. So that would really be what you would look at for an end-to-end structural simulation. Very easy to go through and set up and get some of those high fidelity runs through very quickly. The next type of simulation that I can check on here and run is a modal or a vibrational style analysis. We can go ahead and activate that study here. And what's nice here is that the model is the same. So we could actually just copy the constraints that we had over in the structural study and paste them over into our new study. Makes it very straightforward to get that set up. And from there, we can go ahead and get our contacts detected, similar to how we did with the structural study. Next, we'll set up the mesh for our study. And you'll see that the workflow is going to be very similar up until this point. Again, we want a higher fidelity run. We can have some control over the specific sizes of that global mesh. And now we'll generate the mesh that we laid out there. And overall, again, fairly quick to run through and get that. And one thing that you'll notice in the process manager is that you can see not only the process that's being currently run, but it also shows the full history of everything that we've run up until this point and really get an understanding of what we've worked on in this session. It looks good there. Now, from this point, what I want to do is define some of the setup and the results that we actually want to view from the study. Once we have everything done in the setup and where mesh is good to go, we want to go through and specify what we want to look at. Now, this being a modal analysis, we want to specify how many natural frequency modes that we want to solve for that in this study. On top of that, we can define what we'd like to view in the results. In my case here, I'd like to see a contour plot applied for our first frequency. Do the same thing for the second frequency mode as well. I'd also like to use a simulation probe to view a frequency table for the 4 modes that we'll be running as well. And with all that set up, we can go ahead now and run back through that study. And one thing that I'll mention is the fact that this is probably, in really looking at the model, you can see that this is more close to being finished. If you were running something like a model that's closer to the beginning to early stages of the design process, you'd more than likely be running with something like Creo Simulation Live, much more useful and really a bit faster to go through and get those type of results back. But as you start to get further on in the process and as you want to get more validated and really looking to get those convergent results is where you'd want to turn to a tool like Creo Ansys to get some of those back here. But each really do have their very strong capabilities and their particular use cases they play well into. All right. And with our study complete, we can go ahead and look at some of the results that we got. Now, first thing I'll look at is our frequency table. We can see the natural frequency responses based on the constraints that we had applied in the simulation definition. We can also take a look at our contour plot for the displacement magnitude here on our rear arm assembly. These are the results being taken from the mode 1. Similar to before, we can turn off or on the mesh visualization. You can take it a step further and animate on that deformation as well. Let's go ahead and do the same thing for our mode 2. And with that, immediately we're seeing a much different type of deformation. So this contour plots along with the deformation animation give us a much better understanding of how our model is reacting, how we would probably be behaving under operating conditions. And what I want to move on to now, based off of the results that I've gotten from either the structural or the modal studies that we've done, what I can actually do now is go back into my model and make some changes in order to improve the design or really do some refinements. The main area that I want to focus in on are going to be these brackets. It's where the maximum von Mises stresses were located and the spot that I know I can make some improvements to. This could mean multiple things, whatever I want to go through and do to improve the design. This could mean increasing the length of the bracket here to spread out the stress a little bit. Another thing that I could try is increasing the thickness of the bracket just to make it stronger overall. A couple different options that we could go through and focus over on there. Let's move over and do the same thing on our other bracket. And one of the things I want to highlight here is the changes that I'm making here tend to be a little bit more focused on refinement. The assembly that we're really using here is mostly complete, focusing on validating that my model's been built out correctly. If you were to more of the beginning mid stages, making more, I'll say fairly drastic changes, that is something that would be more geared towards a simulation live study for getting real time, instantaneous feedback on how the model is responding. And then by the time that you have mostly everything built out, you would bring it over into Creo Ansys to get that validation and make sure that the design has been built out correctly and it's ready to send off for manufacturing. All right, let's go ahead and run back through that structural analysis again. And what's nice is because we didn't change the contacts or the constraints, the forces, we just leave those all the same, we can run that same test as we had before. But because we're rerunning the study, the results that we're going to get are going to be a bit different from the first time that we ran the study, obviously. And one of the biggest things to notice that really throughout this entire process, between every single study that we ran, never had to leave Creo. It's a really huge value point throughout everything that we're doing here. And really for a lot of the different extensions in Creo, something I want to point out is the fact that you're using the same user interface. You don't have data translations. You don't have 2 different programs interpreting geometry in 2 different ways. It's all right there within the same easy to use interface that's used in standard Creo parametric. So as compared to someone trying to get up to speed with learning a completely new tool, which could take a long time to get proficient with, staying right within the same user interface that you're already used to working with, it's going to be much more quicker time to value, and you're going to be up and running just that much faster. So something that we see a lot of people starting into Creo Ansys getting a lot of value out of is just the fact that they're up and running that much faster. All right. And once our study is complete there, you can see that it built out the mesh, it did the solving, calculated the results that we're looking for, and now we can take a look through some of those results. So starting here with the von Mises stress, you can go ahead and see that the value is pretty significantly decreased from where it was before. It was at 85, it's down under about 60 megapascals now on our simulation probe over there on the right-hand side. And the load seems to have stayed around the same place as it was before, so it's still functioning the same, which is a good thing. And everything is fully associative. Everything's updated, despite the fact that there was changes to the model. We're able to update for that as well. All right, so that really covers the standard workflow that we follow in Creo Ansys. It's validation analysis, done with Ansys mechanical solvers, and still all right there from within Creo. All right, so before I go into really explain some of the differences, I want to go through and just really, I'll say, cover again some of the main value that we get from working with Creo Ansys. First and foremost is giving us a deeper integration of simulation throughout the entire design process. It's no longer a disjointed system where you have design and analysis in two completely separate worlds. We're really looking to integrate the two together so you can start enjoying the benefits right from the start of the process. It means shorter development cycles, less time sending a model back and forth through a lot of different iterations, and probably prototypes that could have been avoided, saving you time and money. It's also getting our products out to market that much faster and mitigating some of the risks of product failure down the road. And all those things are important, but the most important thing is that we're creating better products. It's products that begin with innovation at the early stage of the design. We're optimizing them during the detailed design, and then finally validating them using those high fidelity analysis results that we're getting from Creo Ansys simulation. So really a ton of benefits that we're getting from working with that throughout the process. All right, and with that, I can take a moment here just to go through and clarify on some of the differences that we have between some of the different simulation products that we have here at PTC and Creo. There's multiple different areas that we work with and some differences between what you're working with. So I mentioned earlier Simulation Live, that's using the Discovery Live engine through Ansys, really again used as more of a design tool. And you can see that there's two flavors of this. You have Creo Simulation Live and Creo Simulation Live Plus. The main difference here being with the plus version of Creo Simulation Live, you're getting access to the fluid simulation capabilities. So still getting everything that you would have from a structural, thermal, and modal perspective, and a lot of the same results, but you're adding on some of the fluid simulation capabilities that you have there. Now, looking at this from more of a wider scale, I'd say as you start to look into more of the higher fidelity and more refinement style analysis with Creo Ansys. We also want to include a bit of a discussion around what we have in some of our legacy products with Creo Simulate and Creo Simulate Advanced. You can see that for a lot of this, it's going to share many of the same capabilities. You can see that the core technology that the two tools use, the Ansys capabilities and the Creo Simulate, which is using the Mechanica solvers, use different types of meshing technology. Creo Ansys uses the H-type element, while Creo Simulate uses the P-type element, but a lot of the same capabilities will still be there. And one thing that I'll mention is that a lot of the new capabilities that are going to be introduced in coming versions of Creo, they're going to be mainly focused in on what we have here for Creo Ansys. Creo Simulate is a very mature tool. It's something that was worked on and refined over the course of many years, and something that we're going to continue to support. But any of the new enhancements that we're going to see coming to our simulation tools are going to be focused in on the Ansys tools going forward. So something to take note of is just the fact that we do have a lot coming down the line here and a lot in the roadmap for what we have in our Ansys products, and something that just with every single release of Creo, you're going to see more and more capabilities included with that. And one thing that I will mention with that as well is that going forward, we're going to be introducing an advanced version of Creo Ansys. So it's going to take everything that I covered today, a lot of the main capabilities, and adding on a lot to that. So definitely look forward to that. And we have the release of Creo 10 coming up. So that around that time, you'll probably get a lot more insight into exactly what you'd be working with there.
Yeah, it looks like that the Ansys Plus is going to be something that's very comparable to Creo Simulate Advanced. And I know Creo Simulate Advanced is pretty good. We have a lot of customers with it. And you know, our resident FEA and CFD expert, Bill Stickney, does a great job in helping people become proficient at using these tools, as well as, you know, for services, because sometimes you run into something that you might not, you might need the software, but you're not going to use it that often. That's where, you know, we also come in here at 3HTI, where we can do simulation services and CFD services for you. So all good stuff. Paul, thank you very much. I appreciate it, man. Good job.
Absolutely.
So keeping with the theme of simulation month, next Thursday, we're going to have a webinar on Creo Flow. Very exciting. Good product and great solution. So we will be giving an overview. Paul, you're doing that next week, I believe.
Yes, I believe so.
You are on the schedule. So great. So we'll see you guys next week for Creo Flow. If you have any questions or you need anything, you can contact us at info@3hti.com, or you can reply to the email that you received as far as the invitation for this webinar. Those your responses will come directly to me. So Paul, thank you again. Jeff, thank you for being on. And most importantly, thank you to our audience for being on. Have a great day, everybody. Take care.